This is number 61 on page 113. A football is thrown directly toward a receiver with an initial speed of 18 meters per second at an angle of 35 degrees. So we have got here, I think there's 3 significant figures in the book. So that's that. This is the initial velocity of the football. This 18 we never use in our equations. Remember, we have 2 equations. X final equals X initial plus V initial times T. That's our everything X. Everything Y up and down is Y final equals Y initial plus V initial. And I should put Y here. I should put X up here because only X velocities go with this, only Y velocities go with this. 18 is a 2-dimensional velocity, so that's the reason we can't use it in these equations. We have to find an X and a Y component. Plus 1/2 GT squared. And I have an XY table I'm always going to use on projectile motion, something thrown in the air. And the variables come from these equations. So final equals initial equals the initial X equals T equals, this is always going to be 0 for us. And if you read, it says that the receiver is 18 meters down the field from the quarterback when it's thrown. But that's not our X final. We're actually going to calculate X final and see how much further he has to go. That's what they're asking is what direction and what speed should what constant speed should the receiver run to catch the football, and in what direction. So that's what we're going to find. So our Y final is 0. The Y initial is 0. We know that because usually when you catch a football, it's thrown at a certain level and then it's going to go. We're assuming that these 2 guys are about the same size, just to make it easy. We don't know this yet, but we're going to find it, the initial Y velocity. G, of course, is negative 9.81 meters per second squared, and T equals, we don't know right now. So we get our calculators and we're going to find an X velocity, and we're going to find a Y velocity. The blue line, of course, is 18 meters per second times sine of 35 degrees. That's going to give us 10 point, put that in your calculator, you're going to give us 10.3 meters per second. So that goes here, 10.3 meters per second. And then our X velocity is going to be 18 meters hypotenuse times cosine at an angle. 18 times cosine of 35 degrees. And when I do that, I'm going to get 14.7 meters per second. Remember, whatever the units of this hypotenuse, whatever the units are here, that's going to be the units for my 2 sides. So the red and the blue are not going to be a distance. You're not going to calculate this and say, oh, that's 14.7 meters. No, it's at 14.7 meters per second. Okay, if I use my quadratic equation, I can plug into the Y equation here and get T, or I can use the quadratic equation. So if I use the quadratic equation, remember 1/2 of G is A, which is negative 4.905. The initial velocity is my B value, which is 10.3, and then my C value is really going to be my initial Y, because this right here is always going to be 0 for us, the final Y. We're going to always set it that way anyway. So just remember, you don't put negative 9.81 in for A. When you do the quadratic equation program and it says A equals question mark, it's 1/2 times 9.81, which is negative 4 points. That's negative 4.905. And that's 1/2 G. When I do all that, I get 2.099, which rounds off to 2.10 seconds. So now I can, and remember, if I have that time there, this is the same time here, 2.10 seconds. And so X final equals 0. I don't have to put that down. It's going to be 14.7 meters per second times 2.10 seconds, and that's going to give me how far down the field the football is going to go. So when I do 14.7 times 2.10 my calculator, I get 30.1 meters. Okay, well the football player has started here at the line of scrimmage. This is the line of scrimmage, and he's already gone 18 meters. All right. Well, the football is going to go 30.1. So if we subtract that, 30.1 minus 18, I get 13. So he's going to. So right here's where he is right now. He's going to have to go another 13 yards, or 13 meters, excuse me, to get to where the football is thrown by the quarterback, so that he catches it. So how far does he have to go if he travels 13? He's got to travel 13 meters in how much time? 2.10 seconds. And that gives me, let's just do this real quick, 13 divided by 2.10. He's going to travel at 6.19 meters per second, and then he's going to have to go down field. So there's parts of this problem that I don't necessarily like. I mean, they give you 18, he's already traveled, but this is how far the ball goes. So you're going to have to subtract. That's kind of, people wouldn't think of that. But what I do like is it helps us fill out the table, get a time. It helps us find out how far down the field the football would go. And that's how you do number 61 on page 113.